Hello, welcome to Train Signal. You're watching this lesson on the VM Direct Path feature. My name is Eric Siebert, a VMware vExpert and an author of 2 books on VMware virtualization. In this lesson, you'll be learning what VM Direct Path is and how it provides faster I/O virtualization for your virtual machines. We'll be covering the specific requirements for using VM Direct Path, as well as limitations when using it, and show you how to set it up and configure it. Finally, we will cover some tips and best practices for VM Direct Path, including when you should consider using it and when you should consider para-virtualization instead. VM Direct Path is similar to para-virtualized SCSI adapters, where a VM can directly access host adapters and bypass the virtualization layer to achieve better throughput and reduce CPU utilization. The difference, though, is with VM Direct Path, you must dedicate an adapter to a VM, and it cannot be used by any other VMs on that host. Like para-virtualized SCSI adapters, VM Direct Path can be used for VMs that have very high storage or network I/O requirements, like database servers. VM Direct Path enables virtualization of workloads that you previously might have kept physical. VM Direct Path relies on a relatively new chipset technology from Intel and AMD and is only available on certain model servers. Intel uses a technology called Virtual Technology for Directed I/O, also known as VT-D, and AMD uses a technology called I/O Memory Management Unit, which is also known as I/O-MMU. These technologies allow VM to directly access server hardware, which normally it cannot do because a VM does not know the physical addresses of the host memory that it accesses. Normally, if a VM tried to access physical hardware using direct memory access, also known as DMA, it would corrupt the memory because the hardware is unaware of the mapping between virtual memory addresses and physical memory addresses used by the guest OS running inside the VM. The VM kernel avoids this corruption by trapping the I/O operation and applying the necessary translations to it. Doing this, though, causes a tiny delay in the I/O operation, which can be avoided by using VM Direct Path, which allows for the remapping of I/O DMA transfers and device-generated interrupts. VM Direct Path uses a special pass-through driver that intercepts all communication between the guest VM device and the hardware device. The pass-through driver performs a translation between the guest virtual address spaces and the actual physical address spaces. It does this by setting up I/O page tables that map the hardware physical addresses to the guest physical addresses. Then sets up a protection domain for the guest OS, which is unaware of the underlying translations and proceeds as it normally would. These pass-through drivers are specific to each vendor's hardware devices, such as NICs and storage controllers, as the command format is often unique and must be decoded to perform the necessary translations. In this diagram, you can see the difference between normal I/O virtualization and VM Direct Path I/O virtualization. In the normal method, the VM kernel controls all the I/O between VMs and hardware devices. I/O goes from the VM, through the VM kernel, to the hardware device, and from the hardware device, through the VM kernel, and back to the VM. Using VM Direct Path, the VM uses a regular device driver and not the VMware specific one, and directly controls the hardware device. For data received from the hardware device, the DMA remapping hardware converts the guest physical address to the host physical address, which goes directly to the buffers of the guest OS without going through the VM kernel. Here are the requirements for using VM Direct Path. Many servers do not support this feature. If you do not see an option to enable this feature in your server's BIOS, then your server may not support it. Currently, only servers with Intel CPUs and VT-D support this feature, but there are some AMD servers coming out soon that support I/O-MMU that will support VM Direct Path. In addition, vSphere 4.0 and Update 1 only have experimental support for AMD systems with I/O-MMU. In vSphere 4.1 and 4.0 Update 2, VMware will fully support AMD systems with I/O-MMU for use with VM Direct Path. The first standard AMD server with I/O-MMU supported by ESX is their new Magni Cores processor with an SR56X0 chipset. VM Direct Path is available for specific models of both network and storage adapters. However, currently only network adapters are fully supported in vSphere. Storage adapters only have experimental support, which means they are not recommended for production use. Here are some additional requirements for VM DirectPath. While VM DirectPath will work with most I/O devices, VMware only supports using it with a handful of devices, which currently include certain models of Intel and Broadcom 10 gigabit Ethernet controllers. VM DirectPath is experimentally supported for storage I/O devices on certain model QLogic and MUX 8 gigabit fiber channel adapters, as well as some models of LSI SAS adapters. You should check VMware's online hardware compatibility guide for the most current supported device information for VM DirectPath. While it is possible to share a multi-device adapter with other VMs, it is recommended to dedicate it to a single VM and not share it. An example of this would be a dual-port network adapter where each adapter is a separate PCI device, but to share a single PCI slot. This is known as a PCI bridge. When you select an I/O adapter that is bridged, all the adapters on that device are automatically selected for use with VM DirectPath. There are quite a few limitations for using VM DirectPath, and many of the features that allow a VM to move to another host are not supported. This is because the VM is essentially chained to the specific I/O adapter on a host server. The host I/O adapters assigned to a VM cannot be used by any other VMs or even the host. They are for the exclusive use of the VM itself. You can only assign 2 I/O adapters to a single VM, and that's it. These can be any combination of adapter types, like a network adapter and a storage adapter, or 2 network adapters. The following features are not supported when using VM DirectPath: fault tolerance, vMotion, storage vMotion, DRS, HA, VM snapshots, hot add of virtual hardware to the VM, and suspending a VM. Let's now take a look at how to use VM DirectPath. You should first verify that VT-D for Intel servers or IOMMU for AMD servers is enabled in the BIOS of the host server. It is not uncommon for this to be disabled by default. If you don't see the option to enable it in the BIOS, then there's a good chance that your server does not support it. You can check with your server vendor to confirm this. Sometimes a BIOS upgrade is needed to access this feature. Let's take a look at an HP server to check to see if it is enabled. Here we have entered the BIOS of an HP ProLiant ML110G6 server. This is the main BIOS screen. If we move over to the Advanced section and move down to Advanced Chipset Control, select that option, you'll see an option for Intel VT for directed I/O. Now the location of this may vary based on the make and model of your servers, as different servers have this in different areas, but in general it's in the Advanced section of the BIOS. Once we select this option, we have the option to disable or enable it. Currently it's disabled. Now it's enabled. So now once we save and exit and go back into vSphere, the VM DirectPath feature will be available for us to use. To mark an I/O device in your host as a pass-through device, which is what VM DirectPath devices are known as, you select the host in the vSphere client, choose Configuration, and then in the Hardware section choose Advanced Settings. Next, you click the Configure Pass-Through link and select a device from the list of presented devices. If your host server does not support VM DirectPath or the feature is disabled, you will see a message that says, "Host does not support pass-through configuration." After you click Configure Pass-Through, a new window will open which will show you a list of I/O devices in the host that you can select from. This can include storage adapters, network adapters, PCI devices, and USB devices. You can choose any device to use with VM DirectPath, but be warned though, if you choose a critical I/O device, especially a storage adapter that is used by the host, you can cause your host to no longer be able to boot. Warnings will appear letting you know that the device will no longer be accessible by the host. If a NIC is already signed to a vSwitch, you will also get a warning. Let's now take a look at a demonstration of marking an I/O device for use with VM DirectPath. We're now going to demonstrate how to mark an I/O device for use with VM DirectPath as a pass-through device. First, we'll select our host. Next, we'll go to Configuration, and under Hardware, we'll select Advanced Settings. Here you can see the VM DirectPath configuration information. Currently, there is nothing enabled for pass-through. So now we'll click the Configure Pass-Through link. That'll bring up a window of all the devices, the PCI devices in the host that are available for pass-through. You'll see storage adapters here, you'll see network adapters, You'll also see notifications if they are in use, like currently we see here for this Broadcom Gigabit Ethernet NIC that it's already in use in the vSwitch, and it's known as VM NIC 0. So now to add a device to mark for pass-through, we simply select it. You'll see a message here that this device is a dependent device. So basically what that means is it's a bridge device, so it's automatically going to select the other device. Click OK. Now we have our device marked for pass-through. Click OK again. And there it is. But we can't use it yet until we reboot the host. So basically at this point it's all configured. You see two of them in there, both NICs, because it was a PCI bridge device. So both NICs are listed in there, and as soon as we reboot the host, they'll be available for use with VM Direct Path. And that concludes this demonstration on marking a device for pass-through. Once you have marked a device as a pass-through device, you must reboot the host before you can assign it to a VM. This is done to release the lock that the host has on the device. Once the host is rebooted, you can assign the device to a VM by first powering off the VM and then editing its settings. Next, you'll add a device, select the PCI device, then select an available pass-through device from the list that is presented. Note it is possible to assign the same pass-through device to multiple VMs, so make sure you check and only assign a device to a single VM. Once you assign the device to a VM, power it on, and the operating system should discover it and load the appropriate driver for it. If a driver is not found, you may be prompted for the location of the driver, which you should obtain from the manufacturer and copy to the VM. Let's now look at a demonstration of assigning a pass-through device to a VM for use with VM Direct Path. We'll select our host, which has been rebooted, select Configuration under Hardware, Advanced Settings. Here's the VM Direct Path configuration, and you'll see now that both devices are shown as available for use for VM Direct Path. Next, we'll go over to virtual machines. Virtual machines must be powered off before you can assign a device to a VM. Ours are already powered off, so we'll select one. Select Edit Settings. Next, we're going to click the Add button. We want to select the PCI device. Click Next. Now we can see the list of devices that are available for pass-through, which are the ones that were configured for VM Direct Path. You basically see the two network controllers that we configured. We'll select one. Click Next. Click Finish. Now we see the new PCI devices added to the VM. Now we click OK. The VM will get reconfigured. And once the VM is reconfigured, that's it. That device is now dedicated to that VM. Once you power on the VM, the operating system will discover that device and it's available for use. That concludes this demonstration on assigning a pass-through device to a VM. Here are some VM Direct Path tips and best practices. It may be necessary to set some additional advanced configuration settings in the .vmx file of the VM in some circumstances, such as you are unable to boot the virtual machine, the device is not working properly, a specific configuration is required, and for sharing multi-device adapters between VM and host functions. See the configuration, examples, and troubleshooting for VM Direct Path guide for more information on how to do this. If you need to remove an I/O device from the host, make sure you first remove it from the VM, unmark it as a pass-through device, and reboot the host before you remove it from the host. VM Direct Path has very limited use cases, should only be used in certain situations when you need the maximum I/O possible on a VM or for security purposes if you want to isolate a NIC to a VM in certain situations such as a DMZ environment. You should consider using paravirtual SCSI adapters instead, or the new VMXNet 3 network adapter, which offer much improved performance over traditional storage and network adapters in vSphere. Right now, VM Direct Path is geared towards high-performance storage and network adapters like 10 gigabit Ethernet adapters and 8 gig fiber channel storage adapters. If you are ordering new server hardware and plan on using VM Direct Path, make sure you contact your server vendor to see if the server supports Intel's VT-D or AMD's IOMMU. Here are some key terms that you should know that are related to VM Direct Path. IOMMU is both a general term for I/O device memory mapping technology, as well as the name of AMD's implementation of IOMMU. VT-D is Intel's virtualization technology for directed I/O, which is Intel's implementation of IOMMU. Here are some links for more information about VM Direct Path. The Configuration Examples and Troubleshooting Guide provides more detailed information on setting up VM Direct Path and will assist you in troubleshooting if you run into problems with using it. The VMware Hardware Compatibility Guide provides information about what specific I/O devices are officially supported by vSphere to use with VM Direct Path. VM Direct Path can provide VMs with an extra I/O boost and can help with applications that have very high I/O requirements that you may have not typically wanted to virtualize. While it may have limited use cases, it's a nice feature to have available for those workloads that may require it. In this lesson, we have learned how to use VM Direct Path so you can take advantage of the I/O performance improvements that it offers to virtual machines. That concludes this lesson on VM Direct Path. Thanks for watching, and I'll see you in the next one.